this is a short demo for the 1DV600 course, for the test part or test theme of that course. And it's supposed to be a helpful example for the test part. So I've written an example application. It's called the greeter application. It's really a Hello World application, more or less. It's a very simple example, and the code that you write and the use cases that you're gonna write is gonna be a bit more complicated for the hangman. But so this example is supposed to showcase the connection between use cases and test cases, and also scenarios, and a bit on how to solve the assignment, not fully, but at least give some pointers. And it's also supposed to be somewhat helpful in how to write this automated unit test. I'm going to show this in Java very quickly, so you're going to need to put in some more work, and if you don't work with Java, hopefully you at least get the idea. So the greeter application is more or less a Hello World application. It shows a friendly greeting message in the user console when you run it. So you run it, and there are two use cases. The first one is called store a name, because the greeter application should greet you with your name. And this is just that use case. It's called store a name. It has no precondition. The post condition of this is that a name is stored, and you need the name to run the other use case, be greeted. So it starts when a user wants to store the name in the greeter application, and the system should ask for a name, and the user provides a name for the system, and then the system stores the name and presents that it has been stored. The use case has an alternate scenario from step 3. So if the user provides an empty name, then it's a separate step. Then the system should show an error message and go to step 2 in the main scenario. That means that the system should ask for a new name that is not empty. And I've depicted this with this activity diagram. It's just that, so here we start, and then we go to the system ask for the name, and then we have the option of going to this 3A step where the user provided an empty name and an error message is presented, and then we go back when the system asks for a new name, and then we go to step 3 where the user provides the name that hopefully is okay, or the user has provided an okay name that means longer than one letter. And the system should then store the name and presents that it has been stored, and then it's more or less quit. I created these small activity diagrams using YUML. I think that is a nice way of doing it, so you can try that out. Also, the second use case is be greeted. It has not really any precondition. It has a post condition that a user has been greeted. So the user starts with the greeter application, and the system shows a greeting message, including the name and the current date. So it could be the case that the user has not stored a name. For that case, we have step 2A instead of 2, and 2A then goes to use case 1. So if there is no name stored, then use case 1 is run, and then you go to step 2, where the step 2 is that the system shows a greeting message. Okay, so we've written a bit of code, and we're supposed to do some testing of this application. It's quite simple application, so let's start with a test plan. A test plan is good because before you start to work, you should have some idea on how to do things. So the objective of testing in this iteration is that, okay, we have implemented some code, now we need to know if that code works as it's supposed to. So that's more or less what I write under objective. test the code that was implemented last iteration. If there is confusion about this, then you could like write this use case is tested. And then I've written a little bit about what to test and how. So we intend to test use case 1 by writing and running dynamic manual test cases. Dynamic means that we run the application instead of statically look at the code or something like that. And I also motivate that we should wait with testing use case 2 until the code for use case 2 has been implemented. This is to show that you can put some testing in one iteration, other testing in other iterations, and you sort of just makes sense. And this is something that I want to see in the assignment 3 also. I also write that we also write automated unit tests for the name.dal class, all the methods in that class, and we should write a name.dal test class. And each system under test method should have at least 2 tests. Finally, we examine the code by static code inspection to see if we can add unit tests to all classes and methods in the future. And I'm thinking about doing that today also. So then I made a quick time plan. So wrote down the different tasks and an estimated time and the actual time that it took. And then I started to work on the manual test cases for use case 1. And if we go up to use case 1 and the little activity diagram here, you can see that there are different paths we can take through this use case. You can go to 2, 3, 4. That is one path. That is what I call the main success scenario, so to speak, when everything goes as it should be. So that is probably a good idea to have that scenario. And then you can have other scenarios like 2, and then you go to 3A, and then you go to 2 and 3 and 4. That could be another scenario where we also have the case where the user inputs a false name. In this case, a name without any letters in it. So my first test case is that we store a name successfully. I just wrote TC 1.1, and TC 1 for me means that this is for use case 1 and the first test case of that. And then I give it a name that should make sense, store name successful. And the use case, I write down the use case 1, store names, name scenario, and store names, and the scenario name is store name successful. You can see that I've made this small image also that is showing the steps that of the use case 1s that we're actually doing in this scenario. So we go from 2 to 3 to 4, and then it ends. I've written a short descriptive text here. The main scenario of use case 1 is tested where a user stores their name successfully. Precondition of this test is there must not be a name.txt file in the greeter data. Remove it if it's there. So this precondition could either be a test step of the setup or a precondition. In this case, I wanted to have an example of a precondition, so I've just written it there. So if we're going to run this, we need to remove the name.txt. And then we start the application, and the system should show fill in a username, and then we write a correct username into this one. And in this case, I've selected the test data, Johnny. And then we press enter. So these are the steps, and the steps should guide the tester through the scenario so that it takes the exact same path each time. In order to do that, you need to specify test data, where to click and what to input in what field clear enough so that every tester does the same thing when they're reading this scenario. And after the test step, then it comes the expected output or behavior of the system. So the expected output here is that the system should show the text name Johnny stored, Also, it should show output from use case 2, if that is implemented. And then I've created a second test case. It's called TC 1.2 because it's use case 1, test case 2. It's called store empty name force reprompt. So use case is use case 1. We have store name scenario with store name and store an empty name force reprompt. I call that the scenario there. So it goes from 2, which was that the system should ask for a name, and then we go to free A instead of free. And free A was that it should give us an error message, and it should also, with 2 again, reprompt us to input a new. Okay, for this one also, there must not be a name.txt file in greeter data. Remove it if it's there. Okay, in order to do this, you should start the application. The system should show, fill in the username. Then you press enter without entering a name. So it's 0 character long name. The expected value is that the system should show the text, a username must have at least 1 character, try again. And again, system shows, fill in a username and waits for input. So here we have test data, that was the input, and it's given in the test steps. It was that actually we just pressed enter without entering a name. And we have expected output. These text strings should be shown. Okay, so let's try out this system. So we go to IntelliJ, and I use IntelliJ here, and sorry that it's not super easy to show, and it's not super easy to show for me either. So in order to run these test cases, we were supposed to remove the data. So let's see if I can find a delete here. We delete that. Okay, so we now deleted the file, and now we can run the main method. So let's do that. Run main. So here we can see the output, and it's a console application, so it writes fill in a username. And let's do the first one. Let's call it Johnny. It's a bit hard to write for me. And then it show name Johnny stored and welcome Johnny. And that was pretty much what we wanted from test case 1.1, right? So started the app, fill in the username, enter the name Johnny, and press enter, and it should write name Johnny stored and also give output from use case 2, which we don't really care about here because it's not implemented. It's actually implemented, but I didn't want to do it. Okay, so let's try the other test case. Test case 1.2, store an empty name, should force a reprompt. And first we start with the precondition, and here we actually have something that is wrong actually in the implementation, and this is the name.txt does not exist even if it should be there, and actually it's called just data in this application, and that's actually a bug. So we should, even if this is not something that we expect in these test cases, we should probably write this in our test report that the name of that file was not the same as in the test cases and stuff like that. Okay, so we should start the application, and then the system should show fill in a username, and then we should run it. So run this again, fill in a username, and then we just press enter. And then it should show the error message, a username must have at least 1 character, try again. And then it should reprompt us to enter a username, fill in a username. So we go back to the test case, and it was pretty much exactly what we expected. So that test case, even if we did not run the application to the end, it actually succeeded. So given from that, we have written a short test report. I've included a test traceability matrix, and just to show how that works, and also how to report successes. So we have two test cases, test case 1.1 and 1.2. Both are covering the use case 1. And I've written here that this means that it covers the use case 1 and also that it went okay, so it's passed this test. And down here we can see that I've written something like coverage, and that means that I've just sum up how many test cases are covering this use case. It's sort of a rough measurement on how much this one was tested, and then also if everyone was okay, I write down here. That sort of means that all the test cases for use case 1 was okay, and that we had 2 of those. For use case 2, we did not cover use case 2 with any of these test cases. It could be argued that since the system shows output from use case 2, that also succeeded, but yeah, maybe. I think that we should have a test case for use case 2 that exemplifies the exact output that use case 2 should show us. So we have not really succeeded here, or we don't know if that works because we have not created manual test cases for use case 2. And we don't have coverage for that, so I just wrote 0. And now let's go over to the automated test suite. So I've created a test for one of the classes, and the class is called nameDal. And it's probably a bit small for you, but nameDal has a few methods. We have hasName, and we have getName, and we have setName, and then we have a method called reset. Each and every one of these methods should be tested. So I've created a test class using, and I clicked the wrong file, a test class using JUnit. And the first test is called setName, should throw an exception if empty name. And I mean, that is the expected output of this method. So the setName method should throw an exception if we input an empty string. So here, just to exemplify this, I've written a string input, and it's an empty string. And then I call the setName method on an instance of the object, and I call that instance SUT, and that means system under test, and I send it the input. SUT is created up here, and this is I reuse this instance between all the test cases. You can have a setup methods and other things in JUnit. You more or less need to learn that yourself. Up here we can see that this test case expects an illegal argument exception to be thrown. If an exception of that class is thrown, then the test case succeeds. The second test case is for the same method, setName, but we send it a proper username. In this case, I just send it a string, an OK name or something like that. It could be more or less anything that is longer than 0 characters. And then I called the method setName again with that input instead, and then an exception should not be thrown. So this test case actually don't have any asserts or anything like that. It's just a complementary test case that has value together with the one that throws. So it shows that given this, it does not throw. If it throws, then this test case fails. Then I have more test cases, and for the next method it's called hasName, and hasName should give us a true if there is a name stored, and should give us false if it is not a name stored. So we call the method reset. It's a method that I've created to remove everything, so there is no names stored, and then I call the method hasName on this SUT object, and it should return false. So I call a method called assertFalse to make sure that that happens. The next one is the complementary test for that, which is if there is a name stored and I store a name with set name. So I send it call set name method with a name, and then I call has name again, and that should return true, and I check that with assert true. For the other method, get name, that's a bit more complicated because this method does have, or this class does secret things on the inside. So in order to test this, I test the get name, I need to set name. It's a bit intertwined weirdness, but get name should really return the same name that has been set before. So first I prepare my system under test. So I have this input string, just some random string again, and the expected output from get name should be the same as the input to set name. So, and then I prepare my system under test by calling set name with that input, and then I call get name, and I expect the expected value to be the same as what get name returns, and the expected value was created up here. I have a second test case for get name, and with a different string. So these are pretty much the same test case more or less, but with different test data. So this test case could be argued that it's unnecessary, but I would say that it could be valuable if there is some kind of bug that makes sure that the first test case succeed. If we have an implementation of get name that always returns this value, then that test case will succeed. This is a bit constructed just for this in order to have two test cases for every method, really. Okay, so let's run these test cases. So I just put run, and I'm gonna, let's run these. And down here in the left-hand corner, I can see that every test case shows green. That means they all succeed. If I go to the implementation of, and let's destroy this class a bit by returning some other string here in get name, and I save that and I rerun these test cases. Now we have a false implementation, and by running the test cases again, we should see that some of the test cases fail, and you can see actually 3 test cases failed, and that is because we have a bit of overlap between our test cases. Okay, so I'm gonna show you one last thing, and that is that I can run these test cases with coverage, and that means that when we run the test cases, we also measure, or IntelliJ measures under the hood how much of the code that is run. And we can see up here is a coverage report, and here we can see that the name.doll class is 100% covered, but the other classes are not. And that shows us that we only really tested that part of the code really good. Okay, so let's go back to the test report, and I've just extracted the important things from the test report and put it in a table here. So, but you're supposed to take screenshots of these, that one, and no, it's that one, in order to in your test report. So read the instructions, should be pretty clear. But here we can see that the test, name.doll test, is really testing the name.doll class. So I just created a matrix with all the classes and all the tests, and then I give some idea that which parts work and which does not. So we can see that these classes are not really covered, and we really don't know anything about those yet. And in the end, I think it's a good in a test report, because this is test report 2, come up with some kind of conclusion. So in this case, the conclusion is that all tests pass. Next iteration, we focus on use case 2 when we have implemented that. And we have not really examined the code, so let's take a look at the code. And I'm actually having a bit of trouble seeing the code, but we can, if I take a look at some other classes, we can see this class. This is a view class. It's working with system in and it's working with system out. And our code review now sees that, oh, maybe it's a bit hard to write automated unit test, because this class is not working with returning values. It's actually putting things in system out as output and taking things as in system in as input. That makes this class a bit complicated to test. Actually, the solution for that is to mock both system in or system out, or to introduce some other fake objects. But more about that in the lectures. So thank you for this. And that was pretty much all for this example of the greeter class.